Welcome back, students. Let's go to the next set, derivatives. Here you have to do some derivative computation. Looks like you'll have to use the product rule for this part, and then another derivative computation here and subtract. Okay, let's go ahead and do that. So we have product rule here. So product rule has this kind of structure. U prime v plus u v prime. So we have this kind of structure. And this one over here, in the end, is for this guy. And that product is this product rule. That's the structure. Okay, so product rule, the derivative of first function times second function. Second function here is log of x. And first function times derivative of second function. First function is just x here. And then what's the derivative of this guy? That's 1. So, all right, that's 1. Let's complete this product rule here. The derivative of first function, derivative of x, that's 1, isn't it? Oops. And finally, the derivative of the second function. What's the derivative of log of x? It's 1 over x. But I prefer power form to tell the truth. In calculus, power form is generally more effective. You will make less mistake that way. Okay, all right. 1 times log of x plus x times x to the negative 1 power, that's just 1, and minus 1, in the end, you get just log of x. So the derivative of this whole thing turns out to be log of x after simplification. Okay, is that the answer key? Yeah. All right, that was easy. Now, this is not going to be that easy. Ready? We have to consider two functions here, this function and that function. And after calculating the derivatives, subtract one from the other. Oops. What did I click? So the derivative of the first function, that's basically it. You see, this part, which I just highlighted in blue, that's one thing. And this part, which I just highlighted in red, that's the other part. So that's blue. And then that's red. That's the structure. Okay, now what do I have here? The derivative of this blue function. And looks like you'll have to use the chain rule. What is the outermost function? It's cosine. Nope, it's not cosine. Look carefully. What's the outermost function? Need hint? Okay. There you go. This expression down here is the same as the previous expression. Let's do this color coding so that you can see the match more closely. So the outermost function here is not cosine, it's second power. That's the outermost function. Same goes here. The outermost function is not sine. The outermost function is the third power. So when you use a chain rule, outside first. So we have to do outside first. Multiply by the power 2. Subtract 1 from the power. Minus 1. So we have just one power, so you don't really have to write it. Times, I have to multiply the derivative of the inside. So looks like I have to multiply the derivative of this cosine of 3 theta. Are you with me here? Let's recap. 2 came out and subtract 1 from the power. Let me change my mind. Let's put this 1 power here. Okay, you can throw this one away because 1 power is as good as nothing. But let's put it back. And then I have to take the derivative of the inside, and that's another chain rule. So what's the derivative of an outer function? Derivative of cosine is negative sign. And inside always stay the same. And multiply the derivative of the inside. Derivative of 3 theta is 3. You can simplify this entire thing like this. So 3 and then times 2, you can rewrite this thing as 6 times, and then negative is there, so negative 6 times all these. Oops. And then I don't need this first power. There you go. I don't need this bracket either. Okay, this whole thing can be simplified into this relatively simple form. I don't need this dot either. So you can be simplified like this, but if you go back to the original problem and then apply the chain rule one at a time, this is a proper format. 2 came out, subtract 1 from the power, and nothing changes inside. Now let's do something about the inside. Take the derivative, and that's another chain rule. Outer function become negative sign, nothing changes inside, and multiply the derivative of the inside, times 3. So this is basically 2 chain rules. 2 chain rules put together. Now, ready to do the same thing here? Ready? So what's the outermost function? It's third power. So 3 comes out, and then subtracting 1 from the power. There you go. And then I have to multiply the derivative of the inside. The derivative of the inside here. And the derivative of the inside, another chain rule. Derivative of the outer function is cosine. And nothing changes inside. And finally times 2. And this can be simplified similarly. 3 times 2 is 6. And then cosine of 2 theta times sine squared I'm losing color either way. Maybe I'll do this one. I guess that's it. So this is the simplification of that one. 3 times 2, that's 6. And cosine of 2 theta times sine squared of 2 theta. Here we have all 3 thetas because inside never changes. Here we have all 2 thetas. Again, by the chain rule, inside never changes. Let's recap. Here, look at the blue term. 2 comes out, Nothing changes inside, and we have 1 power. And then we have another chain rule to go, the derivative of the inside. Cosine becomes negative sign, and nothing changes here, and then multiply the derivative of the inside. That's what we get. That's the blue part. If you simplify, you're going to get this blue. How about the red part? 3 comes out and subtract 1 from the power, so we have 2 power. Inside stays the same, but we have to take the derivative here and multiply outside. So how do you do that? Sine becomes cosine, and again inside stays the same, and multiply the derivative of the inside. So 2 chain rules here. Simplify, you're going to get that part. So 2 chain rules here, 2 chain rules there. Okay, all right. Let's see, do I have answer key here? Okay, all right. Okay. Okay, that way you can see the association a little bit better. Okay, done. Let's go to the next problem. Ooh, a little bit confusing problem here. We have bunch of e's and bunch of x's, and how do you handle that? Remember, e to the something power is exponential, and something to the e power is just power. All right. I guess I need some bigger font here. So from here, let's take the derivative of the outside. So e, the power, comes out as coefficient, and subtract 1 from the power, and inside never changes. That's step 1. That's the derivative of the outer function. And then you have to multiply the derivative of the inside. That's step 1. All right, what's the derivative of the inside here? That's going to be the derivative of this quotient. So let's see, quotient rule. So you have to expect something really long. So if you're using paper and pencil, draw a long horizontal bar and prepare something really long here, which I'm doing here. Let's see, prepare a long horizontal bar. All right, okay. The denominator squared, that part is so conspicuous that hardly anybody misses. Maybe even bigger font. Okay. And then in the numerator, we need the typical quotient rule structure. U prime v minus u v prime. Kind of like this. That's the structure of the quotient rule. Oops. So u prime, the derivative of the numerator, times denominator, numerator times the derivative of denominator. And the parenthesis part, let's just take care of those first. These are just copy and pasting. So u prime v, so u prime goes here, and then u v prime, so that's u, and then that's going to be v prime, the derivative of the denominator. Okay, let's take a bit of a break now. We used the chain rule, the derivative of the outside. Power came out, subtract 1 from the power. And then the derivative of the inside is a quotient rule. So we got the structure. And then u prime v minus u v prime over v squared. We got that. And all you have to do now are going to be putting these two derivatives in, u prime and v prime. And here u prime is going to be a problem we have another product rule here. V prime, that's far less of a problem. We have a power function plus exponential. Power function first, e x to the e minus 1 power. And then exponential always stay the same, and that'll take care of the derivative of the denominator. All good. Now, how about the derivative of the numerator? It's a product rule, so u prime the derivative of the numerator, e x to the e minus 1 power times the second function plus first function times the derivative of the second function. Exponential just stay the same. And that completes the problem. As for simplification, oh, never mind about the simplification. I never care about simplification. Just leave it like this. It is possible to simplify a little bit, I know. I mean, for example, this e and that e to the x put together, you're going to get e to the x plus 1 power. And that's about it. So it's really pointless to consider any kind of simplification, I guess. So okay, I'll just leave it at that. Alright, so much for the derivative problems, and let's meet again in problem set number 4, tangency problem, in a separate video.